Okay, today we're going to have a look at one of your electrical assessments in Unit 153. You've got two assessments to achieve in this unit. This particular one we're going to look at is removing, refitting and testing the alternator. So as you can see, the alternator is quite easy on this particular engine to access. It's right here at the front of the engine. There's the drive belt, or the serpentine belt as it's sometimes referred to. Two connections you have to think about. First one is this main battery live, which is connected to the battery all the time, so that needs to be dealt with safely, and I'll show you that in a second. And this is the control side of the alternator. So as you've seen from your classroom sessions, the alternator is responsible for the charging of the battery when the engine is running, and supplying all the vehicle electrical needs whilst the engine is running as well. So when the job is finished, we'll be testing to make sure that the alternator is putting out sufficient voltage for both those jobs. So if you're working on the alternator, as I showed you previously, we need to break this connection. The quickest and safest way of doing that is just to remove the negative terminal and then position it so that it doesn't actually spring back up and make the connection with the battery. So I'm just going to loosen this terminal here and then remove that and tuck it down out of the way. So just making sure that's kind of caught down the bottom and won't spring back up and touch that terminal. Okay, the first connection I'm going to deal with is the control circuit. It's simply just a multi-plug which is locked into place with a little tab which you can see on the left hand side. I'm just going to simply use a screwdriver to push that in and remove it. Just push it in towards the plug itself and that will unclip it, unlock it, and then we can just ease it off. Never pull by the wires, always grab by the plug. If you pull by the wires, the possibility is you could damage the connection. You could pull the wires out of the terminal. Maybe you wouldn't even know this, and then you've got a poor connection inside which will then be hard to diagnose and will play havoc with the charging system. So always grab a connector plug by the plug, not the wiring. Okay, the next one to deal with is this main battery supply wire here. It's held on by a 10mm nut. I'm simply just going to spin this 10mm nut off. Not particularly tight, and be careful when you do this back up again that you don't over tighten it, because you could damage the threads or the stud that it's attached to. So I'm just going to pull that nut off, disconnect the wire. I'm just going to put the nut back onto the terminal so that I don't lose it. Just a couple of turns and that keeps it nice and safe. And just pull these wires down out of the way so they don't get caught or trapped. If you have multiple wires, or if the two connector blocks look the same or something like that, it's a good idea to mark it, a bit of masking tape, and just write on the tape so you know exactly which wire goes where. So the serpentine belt itself runs around all the ancillaries of the engine, things like the water pump, air conditioning, power steering if it's a hydraulic system, obviously the crankshaft as well, because that's what provides the force. The alternator itself, however, does not tension the belt. There is a separate tensioner on this system which is tucked way down inside the engine. I'll show you that in a second, but I just need to show you first of all how the alternator is attached to the engine. There's two bolts at the top here holding this bracket in place, which is part of the actual alternator, and there is a third bolt down here underneath the pulley which goes in at this angle which holds the alternator in place. So it's located by 3 bolts, but before we can undo the bolts we need to release the tension. I'll show you the tension in a second, but we also need to have a good look at the routing of that belt. It only goes on one way. And if you can't remember the way it goes on, then you will be there for a long time trying to work out its direction. Okay, so I've come to Alternator. It's probably the easiest way to have a look at the routing of the serpentine belt. You could of course make your own drawing. If you can see the whole plan, you could take your own photograph, but I think this is probably the easiest option that we have. So simply just type in the vehicle's details, go to the service illustrations section, and that will pull up the plan for the diagram. I'm just going to zoom in a bit more detail so you can see what these letters actually mean. So starting at the top we have PAS, which is power assisted steering. That's the old hydraulic system. The G is the guide, or the idler. G is generator, which is the thing we're going to take off. The T is the tensioner. WP is the water pump. The CS is the crankshaft, and the AC is air conditioning. So I'm down underneath the car now, taking the wheel off and one engine cover. That's revealed now the other half of the Serpentine belt. You can see just running the spanner along it here. This is the actual tensioner. It's sprung loaded. It's known as an automatic tensioner. So all we simply need to do is work against the spring, and you can see that the belt now starts to loosen, and now I can unhook that belt from the tensioner, releasing it from the alternator, and then I can get back up top and just unbolt the alternator safely. The belt's now released from the tensioner. I'm going to take the belt completely off. I just really want to inspect it and everything else that is kind of driven by it, just at this stage, to make sure there's no problems or issues with it. Okay, so to inspect a Serpentine belt, what we're trying to do is just basically bend it back on itself. We're checking the grooves all the way along the belt, making sure all the grooves are there, there's no nasty cracks or anything. Be a little bit kind of, severe with it, bend it right back on itself. That's the only way you're going to kind of really expose any kind of damage. This particular belt, although it looks a little bit old, it doesn't look in too bad a condition. Maybe just a little bit of a damage there, but I think in general terms this is okay. Just check the back side of it as well. No visible damage coming through on there. So yeah, I'm quite happy to put this one back in. Whilst you've got the belt off, it's good practice just to run your hand over all the bearings and the components that the belt runs. With the general engine noise, it could mask the start of a bearing failure. And the problem we get with these belts, they're under so much tension that when you release the tension, the bearings of these components tend to relax. And when the belt goes back on, they get retensioned, and that can lead to premature failure. So if you forget to kind of check them here now, you could have the car coming back as a return job, and that doesn't look good on the garage. So have a good check and a feel. So I'm feeling the water pump there. The alternator's coming off anyway, so that's okay. There's the air conditioning down the bottom, and we've got the crankshaft, the power assisted steering, and the tensioner and the guide roller behind this engine mount here, which I will check in a second. Whilst you've got the belt off, it's good practice just to run your hand over all the bearings and the components that the belt runs. With the general engine noise, it could mask the start of a bearing failure. And the problem we get with these belts, they're under so much tension that when you release the tension, the bearings of these components tend to relax. And when the belt goes back on, they get retensioned, and that can lead to premature failure. So if you forget to kind of check them here now, you could have the car coming back as a return job, and that doesn't look good on the garage. So have a good check and a feel. So I'm feeling the water pump there. The alternator's coming off anyway, so that's okay. There's the air conditioning down the bottom, and we've got the crankshaft, the power assisted steering, and the tensioner and the guide roller behind this engine mount here, which I will check in a second. Okay, so I've already taken the bolt out of the bottom, just taking this nut off the stud and this last bolt out of the bracket. It's not going to go anywhere, it's sitting on that stud, so it's quite safe. Don't need my spare hand. Just going to put these two bolts back on the bench, and that will now just slide off of here. So you can see now I've removed the alternator quite safely, quite easily, and that's now off the car. Whenever you are replacing an alternator, if you're not using a genuine manufacturer's component, obviously this one is, you can identify that by the badge and the part number, always cross-reference the replacement component, ensuring that if possible part numbers and things can match, any kind of manufacturer's reference kind of matches. At the very least, you want to make sure the output is correct. So here we've got the voltage generated at the alternator and the amperage as well. So just make sure those two match the car, otherwise we could end up with either the battery not being fully charged or the alternator being damaged. With the alternator removed on this particular engine, it gives me a good view of the water pump. So take the opportunity to have a good look around that water pump, checking for any signs of leakage, because this will cause serious engine damage if the coolant leaks from the engine and you've kind of ignored it. So take a good opportunity and check for leaks on that water pump. So as you can see, I've just started the rebuild process now. I've just slid the alternator over the first stud. Just a simple matter of repeating the strip down procedure. So I'm just going to mount the alternator first, put the 3 bolts in, put the belt on, and then connect the wires. And lastly, connect the battery. Once the belt's fitted, you need to do a belt tension check. There are a couple of methods to do this. If you have the experience, you can kind of check it by hand. But ideally, you should be using some kind of belt tensioning tool, and the figure given on the tool would then need to be checked against specifications to see whether the belt is correctly tensioned. On engines with automatic tensioners, there's nothing you can do to tension the belt if it's slack, other than replace the tensioner itself. So this is not only checking belt tension, it's also checking the serviceability of the automatic belt tensioner. The last thing to do then is check the actual belt runs true. So you've checked the tension, it's all fitted back together. Just to spin the crankshaft over a couple of times. As you can see, I'm doing this now, the belt's spinning over. What I'm looking for now is to make sure the belt stays in all the grooves, it's running true, it's not running off center. If it was running out of true, then potentially after a few miles the belt would be damaged, potentially snap, and that would cause severe engine damage. It's just a matter now of connecting up the wires, so I'm just going to remove that 10mm nut that I placed back on the alternator for security. Find the 2 wires. It doesn't matter which order you do this in, the battery is disconnected. I've just picked up the multi-plug to start with. Push it in by the plug, listen for that click and try and remove it by the plug, so you're checking its security. The last thing in is the main battery cable goes into place. I'll then just do up the bolt nut, that just holds that cable in place. Doesn't need to be particularly tight. There's no torque figures supplied for this. It's just literally a slight turn, twist of the wrist, something like that. It's not particularly tight. It's one-handed operation, and that's nice and secure. Just give that a wiggle, make sure it's nice and tight. So finally, I'm just going to put the battery terminal back onto the battery post. Just going to put a little bit of grease inside that battery terminal and the post, just so I've got good connectivity. It's not the ideal stuff, the copper grease. We should be using something, there is specific battery grease or petroleum jelly. Unfortunately, I haven't got any, but I'm using copper grease as a substitute. Just going to put this back on here, and then finally just pinch this bolt up. Again, just a twist of the wrist, nothing particularly tight, there's no torque figures. As you can see, all I'm doing is just twisting my wrist. I'm not even using the leverage of the ratchet, just literally through the actual extension itself. Now we come to the testing to make sure that the alternator we fitted obviously works, and the whole charging system is in good order. If you have a problem with the charging system, it doesn't necessarily mean the alternator is faulty. It could be the link between the two. So before changing the alternator, obviously you would have done your diagnosis to prove the alternator was faulty, but just a final check to make sure that you have now fixed the problem. First test is battery voltage. Always start with battery voltage on any electrical testing you do, so you know what you're working with. Here you can see my battery is charged at 12.38 volts, so just under 12.5 volts. I'm now going to check the battery voltage under cranking to see whether the battery itself is in good condition. I've disabled the engine so it won't start, so it will crank for a longer period of time, and I'm just going to observe the battery voltage. I'm hoping it stays above 10 volts. So test complete, and you can see the voltage has dropped a little bit after the cranking, and it's slowly recovering. Okay, so the next check then is to see whether the alternator is actually charging. I'm going to run the engine tick over. Initially, you may see the voltage doesn't really do very much, might not climb much above 12. If that's the case, I'm just going to bring the engine revs up slightly, and you should see the voltage climb steadily and stabilise at about 14.2, 14.3 volts. So you can see even on tick over the engine is being supplied with 14 volts. We're up to 14.1 now. I'm just going to bring the revs up very slightly just to see what it stabilises at. So as you saw, the revs didn't make any difference at all. The alternator was putting out its maximum output at tick over, and that's the beauty of an alternator, unlike a dynamo where we get maximum supply at minimal revs. Once you've established the alternator is charging off load, we need then to check to make sure it can sustain a load on it, and I'm just going to switch some headlights on, and you should see that voltage in that meter drop by a few volts, maybe half a volt, something like that, but it should stabilise. If it just drops and drops and drops, it suggests that the alternator or the battery has a problem. So as you can see, the headlights are on, and quite nicely the alternator has managed to cope with the extra load. It's not dropped at all, so that's a good indication of a correctly charging system. Final check is to make sure the battery charge warning light is working properly. As you can see, the battery light on the instrument panel is on. It's the top one above the oil pressure and the fuel tank. What you expect to see is when the ignition is switched on, that light is illuminated. The moment the engine is running, that light goes out. This is your charge warning light, so if this was to do anything other than just be off whilst the engine is running, it suggests you have a problem with the charging circuit. Just going to check to make sure this actually switches off. And quite nicely, the charge warning light did extinguish.